if you are able to implement it, nothing like it. Ramco Cements has been organizing this series of webinars since the pandemic started on various topics, ranging from building materials to construction process to reinforcement detailing to smart city to various types of contract methodologies. And sustainability, of course, has been a theme of the organization. And we as an organization have been taking a lot of initiatives, whether it is in the area of energy efficiency, because we have been trying all possible measures to optimize the usage of energy. As all of you know, that cement product manufacturing is. And the second thing is that introduction of blended cement, because how do we use the blending materials to make cement which are green? You know, clinker is limestone is getting depleted, but we need to ensure that our future generations also enjoy the resources. So we need to optimize on the natural resources that is available. So to that extent, the introduction of blending materials without sacrificing the quality of cement, because what we need in concrete has to be there. So without sacrificing that, Ramco Cements has been able to bring a lot of blended cements, whether it is a Portland Pozzolana cement, various brands of cement, you know, which can be customized to the customer requirement. So in fact, we have 12 varieties of cement that are there in the marketplace as of now, which has been customized to various concreting application. So what we do is that we try to understand their requirements, the way they are going to, where they are going to place the concrete, which type of concrete structure, what type of methodology that they are going to follow. Say, for example, if it is an RMC unit, they would be blending materials. Whereas if it is an individual house builder, he can directly use the blended cement. So those kind of customization we have been able to bring in. And our Ramco Research Development Center, we have been doing a lot of work on the various blending materials that are there, whether it is, you know, the hydration, the lower heat of hydration, how to reduce the lime leaching, how to enhance durability. Very important thing. Although concrete is having high embedded energy, but then when we are able to enhance durability, I am sure that sustainability to that extent is fulfilled. So it's a kind of balancing act that we are trying to do. And sustainability is at the center of all our operations, whether it is in the area of mining, using of surface miners, we have been taking in our organization to ensure that sustainability is at the core of our operation. And that is why we are very much interested in topics like this. And I'm sure that professionals would have a lot of key takeaways. So let me invite Dr. Santosh to take over the further proceedings. Over to you, Dr. Santosh.
Yeah. Thank you very much, sir. So, seeking the blessings of Jagadguru Shivratri Rajendra Mahaswamiji and the present pontiff Jagadguru Shivratri Deshikendra Mahaswamiji, on the behalf of JSS Academy of Technical Education, Bangalore, in association with Association of Consulting Civil Engineers, Bangalore Center, and Mrs. Ramco Cements Limited, we welcome you all the participants for this second session of webinar. For today's topic is Demystifying Green Building Edge Discovery Workshop. And I take this opportunity to welcome Architect Vasudevan sir. And I request Mr. Krishna Prasad to give a brief introduction about Architect Vasudevan sir.
Good afternoon, Santosh. Good afternoon to everyone. I would like to introduce our institution, JSSIT, and also our guest speaker to all the participants. So, about JSSIT, this is Jagadguru Sri Shivratreshwara Academy of Technical Education. JSSIT Bangalore was founded in 1997, and it is an integral part of JSS Mahavidyapita, Mysore. So JSSIT Bangalore has been providing value-added higher education, engineering and technological science. And with the blessings of Jagadguru Sri Shivratri Deshikendra Mahaswamiji, 24th Pontiff and the President of JSS Mahavidyapita, Mysore, JSSIT has continuously striving for excellence with very good infrastructure, facilities, state-of-art laboratories, and competent faculties. JSSIT Bangalore is approved by AICTE New Delhi and affiliated to VTU, Visvesvaraya Technological University, Belgaum. Karnataka, and all seven undergraduate courses of JSSAT is accredited by the National Board of Accreditation, and also a gold ranking in QSI gauge. And coming to our guest, Architect Ar.Vasudevan R Kadalayil is a director and principal architect, Ecumene Habitat Solution Private Limited, Bangalore. Architect Vasudevan is practicing architect and the green building policy consultant. He is the principal architect of Ecumene Habitat Solution based from Bangalore, India, which he co-founded with his partner, Mr. Ar.Vasudevan and Mr. Hegde. He has expertise in designing of hotels, conventional centers, sustainable and affordable house, schools, industries, and private homes. He graduated as an architect from MIT Manipal in 1995 and later completed his master's of design science in energy conservation from University of Sydney, Australia in 2002. In fact, while in Australia, he has received some of the recognition like John Dixon Prize in Energy Conservation 2002, University of Sydney, Faculty of Architecture, Dean's Honor 2002, University of Sydney, and his firm, Ecumene, is a recipient of awards like NDTV Grohe Design and Architecture Award 2015 for Master Planning and Rejuvenation of Kaikondrahalli Lake, Saint Gobain Economic Times Smart Green Award 2016 for Conservation, Heritage and Public Utilities. He has also been instrumental in creation of green building codes for Colombia and Indonesia through the World Bank. These codes have been legislated and are being enforced. He is currently member of World Bank team conducting building regulatory capacity assessment for the government of Kerala, and he is also invited as to numerous architecture school as visiting faculty. We welcome you, Architect Vasudevan, and please take over and start the proceedings. Dr. Santosh, you would like to add something?
No, sir. It's over to Vasudevan, sir.
Okay. Thank you.
Thank you very much. Good afternoon, everybody. At the outset, I would like to thank Ramco, the JSS Academy, and ACCE for having invited me here. I consider it as my good fortune to spread the word of green buildings and demystify it really, to mention that it is all very simple and it is easy for us to apply in whichever role that we may play, either as an architect, civil engineer, as a PHE engineer, as a electrical engineer, for other people. Very sustainability so closely. Cement is integral to our building construction, and it is important that companies take note and they continuously keep reducing their embodied energy, which is also going to be a part of my talk when we come to that particular point. So let me just take you through the contents of my presentation. So I have about 10 sub chapters, if I can call it that. And initially, I will just do a very quick introduction of the firm that I helped co-found with my partners. The next thing is to just give a sense of the times that we live in, what is happening to the earth, and why is it that all of us need to sort of take note and sit up. I want to talk a little bit about global warming, and then coming into the more technical aspects of our talk, which is to do with how buildings can be designed and what are the key areas that we have to pay attention to in order to make the building greener and greener. That is the chapters which cover passive solar design all the way to embodied energy. I want to talk a little bit about and the work that we have done when we did the green building codes. And at the end of it, I would like to also take you through a very interesting tool developed by the International Finance Corporation, part of the World Bank Group. The tool is called EDGE, and that is something that I'm sure will be helpful for young building professionals in order to look at how you can make your building greener. So I will go on to the next slide now, which is an introduction about ourselves. We were, as a firm, we were founded in 2010, and we operate in architecture, interior design, master planning, urban design, and sustainability or green building consultancy. We are three partners, as explained by Mr. Krishna Prasad, and we have a 30-plus team of young architects and civil engineers, very passionate about the work that we do. And we kind of make sure that there is innovation in whatever projects that we design. We were also fortunate to be recognized by organizations NDTV, where we won the Design and Architecture Award for a work that we did on the rejuvenation of a lake, which I will talk to you about later in the presentation. We also got recognized by Saint Gobain and Economic Times. That was in 2016. Just a very quick run through of our projects. All our projects have a common thread of sustainability run all through all through the designs that you can see. We have done various kinds of work, commercial. This is a convention center we are doing in Mangalore. This is a liberal arts college we are doing in Coimbatore right now. A hotel that we recently finished. Some technical aspects of this I will be explaining when talk about green buildings further. This is a resort that we are designing in the Western Ghats in Karnataka. This is a very interesting housing project for people from the Central Paramilitary Forces. So that is something that we are doing. This is a sustainable villa development that we are doing in Bangalore, where every villa will have its own solar panel roof. And so we are making it all self-sufficient in terms of the electricity that we are producing here. This is a IEC pre-certified building that we did a few years ago. Again, this building will be explained a little further in terms of what are the features we did here. These are some of our homes that we are doing currently, and some industries. We also were involved in some interesting work on the National Green Building Code, and I will explain this further to you as we go further. This is the a snapshot of EDGE Green Building Assessment Tool that I will talk about. So coming to the second chapter, which is essentially about the times that we live in. We will probably be having this talk for about an hour from now. And just to give you the magnitude of what will happen in this 1 hour, let me just start. So we will lose about 9,000 acres of forest. So Earth is losing, or we are deforesting at about 9,000 acres every hour, in which India will probably be deforested by about 63 acres every hour. We continuously lose various species of animals. So about 6 species get extinct every hour. Our global population is going to increase by about 7,200 people by the time we finish this talk. India itself will witness about 2,000 births, also about 600 deaths, and our effective population rises to 1,400 people every hour. Globally, about 200 people will die, 200 children will die due to poor sanitation. And about 7,000 new cars are produced globally every hour. Of course, these are pre-COVID-19 statistics, so it would have downward revised now. Out of which about 250 new cars will be produced in India alone. So global warming, I think there has been a lot of debate about whether global warming is all hogwash, whether there is no basis, that America is getting cooler, and so the president of the US is saying, look, what global warming is happening, all those kinds of things. But I think it is fairly safe to say that we are in the midst of various symptoms that today we are seeing in terms of global warming. Just a few images to bring you those facts. The polar ice caps have been melting, and what you can see on the left is the polar ice cap as it was in 1980, and on the right you can see that it has depleted. This is an image from 2012 where you can see that it has depleted much more now. Montana, a state in the US, had about 150 glaciers in 1920. Glaciers, as you know, are the sources of many rivers. And in 2020, there are just 27 glaciers left. Our own Gangotri, from which the Ganga flows, there have been, you can see on my screen, you can see the level at which it has been receding backwards. So you can see the how it has receded in 1780 onwards, and how it has receded further. So we are going to witness dying rivers, especially the ones that are born in the Himalayas. A long time back, about 10 or 11 years back, a lot of the small island states, as they're called, SIS, they are the first set of people who are going to be affected by global warming and the rising sea. Maldives government in protest actually held an underwater cabinet meeting in October 2009. So this is just an image of somebody signing a petition that was supposed to be sent to the UN to look at the problems of small island states. Many small island states have already started looking for land elsewhere. They intend to purchase land and relocate their populations over the next 15 or 20 years. Tuvalu in South Pacific is another such island. We are also suffering extreme water stress. India is one of them, as you can see in this map. So there is the redder the color is, the more water stressed it is. And you can see India is one of the most water-stressed country in the world. It is almost similar to other desert-like climates, if you can see that. Now coming to what, these are the more technical aspects of green buildings. Things that I was very much inspired by when I was a student is this writings by an architect called Malcolm Wells. So I've just put a little sketch of his, which shows an earth-bound shelter. He was in the 1960s and the 1970s, one of the first few people who started not necessarily daily energy. It does not respect the total. It results in adverse effects on the environment. So Malcolm Wells was a huge inspiration for a lot of us who were studying in the late 90s, and not many people will know about him, and he was sort of one of the torchbearers of sustainable architecture. Design. So when we say passive, it means that these are non-machinery components of a building design. So when you say non-machinery, it means the outside wall, the kind of windows, the type of roof, the type of floor slabs that you will have, everything that has to do with how a building interacts with around. Now, there are two important things a human being requires when it comes to his physical comfort. So one is the thermal comfort. You want the building to be able to keep you in a decent amount of and if without or aid of an air conditioner, that means the building is actually doing its job well. The second one is about visual comfort. That means that you want to have a space that is well lit, where you would be able to carry out your activities. Sunlight also is important as much for physical health as it is for mental health. So as you know, a lot of us now have vitamin D deficiency, which is essentially because we are all generally more and more sedentary, and we spend a lot of our working hours inside the buildings. And so because of this becomes a health issue. So light is not just for visual comfort, but it also has an impact on our health. Not only that, it also has an impact on our psychological health, our mental health. A well-lit space generally helps elevate your mood. So these are the two things. Now, if a building can do these two things without resorting to any artificial means or active means, that means it's a fairly well-designed building. So if I can design a building which relies less and less on any kind of artificial methods of cooling or lighting or heating and lighting, depending upon the climate that you are in, that means that I am relying less on electricity. If I'm relying less on electricity, it means that our greenhouse gas emissions can reduce. What do I mean by this? It is because electricity is produced in India. More than 60 to 70% of electricity is produced from coal and thermal power plants, essentially, which is electricity produced by burning coal. And if we can bring down the demand side, that means we are bringing down the supply side, and that really helps in reducing the amount of pollution. So if all buildings were to turn green, that means less amount of coal needs to be burnt. So it's a very simple sort of a fact, but this is how an architect or a civil engineer can really think about his building design and be able to do something about it. Now, what are the principles that we need to follow in this thing? So one of the first thing is to understand how the sun moves across the sky. So we all know that sun rises in the east and sets in the west. But how does that sun then interact with your building? So one needs to understand one path. And at different parts of the year, the sun has different angles at which the sun is hitting the building. So during it is one way, during the winter it is another way. So in Indian languages, you call it the Uttarayana and Dakshinayana, and we have just entered the Dakshinayana now after June 22nd, and that means the sun is going further south vis-a-vis your location in this depending upon where you are. So this is an extremely important thing. If an architect can understand how the sun moves across the sky, then he can ensure that his windows are placed in the right direction. If you could understand how the sunlight enters your building, then you will want to cut out parts of the sunlight which cause a lot of heat, but at the same time let those parts of the sunlight that brings in light. So it depends upon how you can intelligently orient your windows in the building itself. So just to give you, there are software tools available where you can actually put your building model and then understand how the shades and the shadows are being formed. And according to this, you can actually plan the way you want to do your building design. Now, the other thing is building and heat. So obviously, I am only talking in the case of a tropical weather like ours. Heat is the biggest challenge that we have, and we have different kinds of amounts of heat depending upon the orientation that we are in. This particular graph shows, for example, that on the x-axis are the different orientations to which your walls are, and on the y-axis is the amount of solar radiation that is coming and hitting on the walls or on the surface of the building. So that solar radiation is measured in watts per meter square per day. That is, watts is the heat, per meter square is the amount of surface area, and per day. So if you see here, eastern and the western ones have solar radiation. So this gives you an idea that on east. Now, if you see the that is the one that actually takes the most amount of solar radiation because it is exposed right from the time the sun rises to the time the sun sets. So if you could shade your roof, then you can actually have a much cooler building. So this is just an example. There are different measurements like this. This measurement also changes from latitude to latitude. So depending upon which location you are in, you can have a different figure to it. So this is how you could sort of, this is a simple diagram that I have drawn, which basically shows you how you should orient your building. The diagram on the left, which has larger faces on west and east, will have more amount of heat coming in. Whereas the diagram on the right, which has a green tick, you could actually have a much cooler building. So a simple thing like orientation of the building makes a lot of difference in the way you will consume energy. And remember that when you actually design a building, you have designed it and that building is going to stay there for 50 years, 100 years, 150 years, depending upon the longevity of the building. So whatever you do in paper has a long-term effect in terms of operational energy of the building. So that is something that we need to be extremely responsible about. Now, the second thing is in terms of glass properties. So glass is a super material when it comes to the way it has transformed the way our buildings are lit now. Earlier days, we didn't have access to glass. In very old buildings, you will see that the shutters were made of wood, and you either opened the shutter or you closed it. When you closed it, you had total darkness. When you opened it, you had both air and ventilation plus light coming through. But glass kind of changed all that. But one needs to understand what are the properties of glass. So the way heat gets transmitted are through three ways. One is through radiation. That means when you stand out in the sun, you have direct radiation that is falling on your building. The second thing is through the air temperature. So the air itself has a certain amount of heat, and that also transfers through. And the third thing we need to understand is how much of light is really coming through. So these are the three aspects of a glass that one needs to understand. If you look at the right side of the slide, you will see how glass is, how heat transfer happens across glass. So when it comes to a single pane glass, your heat transfer is in the range of 5.2 watts per meter square Kelvin. That means for a particular meter square of a surface, you are having 5.2 watts coming in for every degree difference between the outside temperature and inside temperature. It is time is a little short for me to explain this to you, but what I want you to understand is that you have glasses which are either single pane glass, insulating, coated insulating, or three pane, which is high. These are all, and you can see how the amount of heat that is transferred by these various types of glass reduces. So it is very important to choose the right kind of glass. This is extremely important when we are talking about commercial buildings, where nowadays we have a fashion and a passion to do a lot of glass in our buildings. So what are the effects, the downstream effects of using glass? So on the right hand side, you can see two images. One is a glass building with a lot of shading in outside the glass, and the one below is a building that has no shading at all. So what happens is that, let us say both these glasses were of the same type. Then if you come to the hand-drawn diagram on the left-hand side, what it really means is that in order to keep you comfortable, you need to have more air conditioning, because you have unshaded glass. So there is a lot more heat coming in. That heat needs to be taken away by the air conditioner, which means that in a typical commercial building, your air conditioner, if it's a fully air conditioned building, will account for about 60 to 65% of your total electricity bill. So which also means that your transformers have to be upsized, and that means that there is a higher cost. So you have a bigger transformer and a bigger air conditioning system that you will need. The moment you start shading your building, that means you are bringing down the heat load, and thereby you're bringing down the air conditioning load and your transformer. So not only are you saving on your operational cost, but also your capital cost. So this is very important, and this is a very, very important aspect of designing buildings. Now we come to a simple thing like shading, and we need to understand what kind of shading that you do for what kind of surfaces. As a simple thumb rule, typically you go in for a vertical shading on the eastern and western facades. The reason is most of the time, by the time it's about 10 or 11 o'clock, your sun in the morning sun has already gone overhead. So, but it is in the morning that you will really need to shade your building. Now, what happens in the morning is that the horizontal shade does not help. The sunlight will come in because the sun is at a low angle. But at the same time, the sun is never always due east. Depending upon whether it is summer and depending upon the location of your latitude, the sun's angle keeps changing every day. So it is more effective to do a vertical shading on the eastern and western facades. On the northern and southern facades, your sun angle is already high, because typically the north or the south gets sun only from the mid-morning till about mid-afternoon. So it's already high up in the sky, and thereby you can do a horizontal shading. So it's a very simple thumb rule that you can follow. And then you have multiple combinations of it. Sometimes your building is oriented towards northeast or south, northeast and southwest, or southeast and northwest. So then you could go in for what is called as an ecrate shading, which both cuts the vertical sun angle as well as the horizontal sun angle. So it's a very simple sort of a image that I've put out here, but I'm sure it will explain what I'm talking about. So those are the passive aspects of building design. If you take care of how much glass your building has, what kind of materials your building is going to be made of, and what kind of shading that you're providing for your glass, you have basically taken care of a lot of the building related or the passive aspects of your building. Then comes the active systems. In active systems, then thereby you also have many different kinds of machinery that you will be putting in. So you will be putting in lighting, you will be putting in air conditioning, you will be putting in pumps, you will be putting in fans, all kinds of equipment that goes in. You need to make sure that whatever you choose is of a higher energy efficiency. So that is what I'm going to explain in the next few slides. So this is the building that we did in Mangalore. It was a 100-room hotel. But what was important here for us was to ensure that the hot water is done with a sustainable source of heating. So what we really did was to use a solar water heating system, which did all the primary heating of the water. So this made a huge impact in terms of the amount of electricity bill or the amount of energy that the hotel would use. So, so this was something that we kind of looked at, and this is the amount of solar water heater panels that you require for a 100-room hotel. We also did something else. So on one side, we looked at hot water systems, which would bring down the amount of energy. So that was on the demand side. On the supply side, we also said that the rest of the terrace can have as much solar panels as we could put. So in this particular case, we put about 30 kilowatt peak solar panels. In fact, if we had more roof area, we would have put even more. The client was actually ready to spend. But this actually brought down the amount of energy consumption on a regular basis. The next thing is, again, simple things like LED lighting. Now, LED lighting has become quite common now. It is we very little depend on CFLs and other kinds of lighting. So LED lighting really has brought down the amount of energy consumption for lighting that is required. So this is just an example of one of our projects where we did some innovative way of LED lighting. So those are things on active systems. There are many other aspects. For example, the fans that you choose can be energy efficient. You can look for appliances like air conditioners or refrigerators, which are BEE certified. So you would see that there is a 5-star rating. It is always good to buy the 5-star equipment, because they might be expensive initially, but they will help you in saving the amount of energy and hence cost. So there are many other items which I have not covered here. I have just looked at very important 2 or 3 items in the active systems aspect. In terms of building water efficiency, now when we talk about water, water is probably even more challenging than electricity. In electricity, we have solar PV, we have wind, we have a lot of alternate sources of energy, which will help us in sort of take care of that particular challenge. But when it comes to water, water really is a finite material. It is something that is limited in its quantity. And hence, it is very important for us to use water in a very prudent and a very efficient way. So I'm looking at this. I've put across this particular flow chart, which essentially talks about what your water conservation strategy should be. So on the left hand side is the supply side, and on the right hand side is the demand side. On the supply side, you are essentially trying to see if you can depend on a more sustainable way of water supply. So the first thing that you could do, rainwater harvesting, and you either your water needs, or you could have a borewell into which you are putting down your surplus rainwater and then drawing it back whenever you require. So there are different methods of doing it, but it's very important that you can actually you can study the kind of rainfall pattern that you have. Look for the statistically look for the driest sort of spells that you will have, and then you can actually very easily calculate the amount of rainwater that you need to store. The second thing is about recycling water. So whatever water that you use can also be recycled. So your STP, there are very good sewage treatment plants today available where you can actually reuse your flush water and your STP treated water for flushing and for landscaping. If you do go one step ahead in terms of ultrafiltration, that you can actually even use it for other potable uses. So Singapore is an excellent example of this. Singapore has always been a water deficient country, and for the last many years now, they have been actually recycling all their sewage treatment plant water and supplying it back as potable water. So that is something that's an excellent water conservation strategy, both at a city level. You can do it at a very small home level also. The right hand side is in terms of demand side. So on the supply side, you look at alternative sources of water which are sustainable. On the right hand side, you look at consuming lesser and lesser water. So today, one of the most important things, in fact, the first 3 points are all about water efficient faucets, water efficient flushing, water efficient showers. You do get, if you ask the company from whom you're buying your faucets, they will actually declare how many liters per minute is the consumption. And now you get for the same level of wetness, the same wash feel as they call it, you will get more and more efficient faucets. So that is one very important thing. The other aspect is about water efficient landscaping. There are very simple thumb rules to do water efficient landscaping. One is to avoid exotic plants which are not native to your soil. And the ones that are native to your soil will always be more water efficient generally speaking. And there is, you can also do what is called as xeriscaping, that is using the desert varieties of different plants which can survive in less water. So water efficient landscaping, and then also depending on the kind of irrigation systems that you use, you could go for a drip irrigation rather than regular piped irrigation. So there are many ways of doing that. So this is essentially an overall water conservation strategy. Again, I am simplifying it here so that you understand the main components of these things. Just a few examples of what we have done in a couple of our projects. This was a school that we did in Tamil Nadu where the entire roof water was collected, and the courtyard in the center of the school was actually a huge water tank. That we could store about 2 lakhs liters of water. It's an arid region here near Madurai, so we were able to kind of collect water and store it and then use it during dry months. The other thing that we did here was to also have water efficient fixtures, and we also put in a 5 kilowatt solar plant so they don't really need to depend on electricity from outside. This is another high-rise building that we did, where we did a lot of rainwater harvesting. We also did injection bore wells, where we actually put back water into the ground. These were deep injection bore wells that we did. We of course used a lot of water efficient fixtures, and the landscaping that we did was all water efficient again. Now the next portion, which is embodied energy. Now embodied energy is something that people are now slowly waking up to. We always have been talking about eco-friendly materials. So what really an eco-friendly material really is that it should have taken the least amount of energy for its production as a building material. So typically you will have, if you see this this particular aspect of life cycle assessment, that is, any material has a life cycle. So there is energy that is required for resource extraction, there is an energy required for manufacturing, there is an energy required for on-site construction, and then there is energy which we talked about earlier, which is about occupancy and maintenance, and then there is an demolition that happens, and then disposal. Now typically this kind of a cycle is called cradle to grave. That is, this is the cradle where it starts, which is the resource extraction, and the grave is when it goes into landfill. Now there are different concepts that are there. There is cradle to gate, which is essentially you look at how much energy has been used for you to bring it from the point of extraction to the point of use as a building material. That is cradle to gate. There is also cradle to cradle, which is really pushing the entire idea of recycling building materials. So research happening in many places, many universities across the world, where they're trying to create building materials that will have an end of life use as something else. So that's something that is important. Currently, what we should be concerned about at this point in time is the embodied energy, that is the amount of energy that is used for it to start from cradle to gate. So that is something that I wanted to show you. There are these two images that I'm showing on the left and right. And typically one would think that bricks, which is on the left, is more eco-friendly than concrete blocks, which is on the right. But when you actually measure it, and that this is why it is very important not to just go by our visual feel, but actually to look at actual scientific measurements. You can see here on the left-hand side that burnt brick uses about 1,600 megajoules per square meter of the building that it is built for, whereas an equivalent building built with concrete solid dense concrete blocks takes only 1/4 of it, that is 400 megajoules per square meter. So you can see here how appearances can be deceptive. So when you have access to some information like this, it helps you make your decision making more and more stronger. It also then gives a reverse information to the market, as more and more people will start opting for building materials that are based on embodied energy. You can see that there will be a true move towards making building materials more and more sustainable in its production. So this is something that is extremely important. There is a lot of data which is coming out now on embodied energy of various kinds of materials. Production processes are becoming standardized across the world. So data from one part of the world could be used for data in another part of the world, especially for aspects like cement and steel and these big ones. Just to give you a sense of what Dhaka in Bangladesh has a huge amount of brick kilns that is there, and brick is one of their important building materials. But they also cause a huge amount of pollution. So at one point, Dhaka this pollution, 58% of it was created from brick kilns. This is just to give you an idea of how that happens, So, so, so this is just one example I'm giving you. There are many other things. You could be looking at flooring. You could be looking at the kind of windows that you put, whether you want to put a timber window, whether you want to put a aluminum window, or whether you want to put an UPVC window. So each one of them has a certain embodied energy. So that kind of sums up my ideas on how you could make a building more greener. Here, the next chapter is to talk about urban sustainability. So, how is it that we look at this in a larger context? How do you start looking at many aspects of urban sustainability? I have just touched upon a few items. This is by far not a comprehensive list, but just a few things based on my own little experience that we have. There was a plotted development project that we did recently, and one of our clear concerns was to ensure that the way we design our roads, because like I said, building will remain for 40 years, 50 years, 100 years. But when you do a road and the width of the road and the properties of the road, what goes under the road, those road patterns tend to stay with you for centuries, actually. So it is with a lot of responsibility that architects and urban planners need to look at how you plan roads, what are the services that you put under a road, and how is it that you structure the entire thing. So this was just a master plan of the project that we did. But what I want to really explain to you is, various aspects of a street design. These are some simple things. These are not rocket science, and this is not something that people have not done earlier. In fact, in the West, it is becoming increasingly common to do roads in an extremely scientific manner. And a lot of private developers in India also have started adopting these things. So some of the simple things that we looked at was, for example, a narrow carriageway, which is the vehicular aspect. So why we wanted to do a narrow carriageway is to reduce speed. The best way to reduce speed in a layout is to actually narrow the amount of lane width, and thereby automatically people will start driving slower. So that was one of the things we realized, that speed bumps are not really as effective as narrowing the carriageway is. The next thing was to actually provide good walkable spaces on either side. So while it may not be a part of sustainability, but or rather sustainability from a global warming point of view, it is definitely very important that you have walkable cities, walkable towns, because then you're not only reducing the amount of pollution that you would be causing by taking a two-wheeler, maybe just to do a half a kilometer stretch. People in India will take a two-wheeler to go to the market, but if you had really well paved roads and good footpaths, you would actually end up walking there. It not only saves some fuel, it's much better for your health. It also discriminates less against the infirm, the old, the poor people, who may not have access to vehicular access. So that is something that I wanted to make sort of a point of. The other thing is in terms of the way the drains are done. You can see in this corner, there is a little saucer drain that we have done here. Now, typically, a lot of us go with box drains, and box drains tend to get silted during the, just after the rains, and then the water carrying capacity of these drains get reduced. So we have started converting a lot of our designs away from box drains into saucer drains. And each of these saucer drains, again, then have an underground bore well. So at about every 30 or 40 feet, we do an underground bore well, which collects the water and basically hydrates the land beneath, or the soil beneath, and that in turn helps better tree growth. It helps in controlling flooding. There are many other aspects that you can really think about. So this is a photograph that I had taken when we were sort of laying the road, just to give you an idea of how the construction is. We really didn't spend very much extra in terms of the cost. So it was still quite cost effective, the whole thing. This was a lake that we had helped restore some time back. It is, Bangalore used to have more than 1,000 lakes. These are all man-made lakes made by farmers who wanted to. So each village probably had a lake where you would take a low-lying area and then construct a bund around it, and then make sure that all the water kind of flowed into it and they stayed within that. And over time, these lakes had an intricate system where if one lake overflowed, then you had a canal that connected one lake to another lake, which is downstream, and you had a system of lakes here. So if people are interested in just looking at the lake ecology of Bangalore, it's a very interesting subject, especially for those who are civil engineers, who are looking at becoming PhD engineers. It will be something that is worthwhile in terms of understanding. We did this very interesting lake, and it was not just us, but there were community activists there. There were ecologists involved. There were many people involved in this, and we all kind of put our heads together and helped revive this lake. It's about 48 acres. There is a very interesting film that was made on how a community got together and revived the lake. So you're free to kind of look at that. You just type in Kaikondrelli Lake film, and then you will get a interesting half-an-hour film on it. But typically, we did a lot of interesting community aspects. For example, we created an open-air theater, which is used by the people quite a bit now. And there is a Kalyani that we created so that we didn't have people dumping their idols as a part of their Visarjan. The Ganesha idols and Durga Puja idols into the lake itself. But we created a separate Kalyani from which all the non-dissolvable matter could be then taken away by the corporation later. So this is how the lake looks today. It is sort of enriched the entire, the overall place. This is the open air theater. We also created a nice jogging and cycling track, so that people could use it without disturbing each other. Now coming to green building codes. So I'm sort of, if you notice, I'm sort of going from buildings to urban to now areas which are more technical or more legal in its content. And I was very fortunate through the International Finance Corporation, who appointed us as consultants to work on 2 projects. But essentially, I just want to give you a sense of what is the space for green building codes. So I think I wanted to kind of create a distinction between what is a green building code and what is a green building rating system. So if you see here, on the y-axis, you have the number of buildings, and on the x-axis, you have the complexity of green measures. So the intent of any good developed society should be that we have these very interesting green building rating systems like LEED, IGBC, Griha, EDGE, all these kind of different rating systems, which are sort of the market leaders. So there are those people who want to really kind of excel and really go into becoming the most efficient of the buildings, the most sustainable of the buildings. They can approach these different organizations and they will do a green building rating system. But there are the bulk of the buildings which are unregulated or non-regulated. these need to be captured by a green building code. That means you need to have a minimum level of building performance when it comes to energy or water consumption. And that is what we really did in Indonesia and in Colombia. You can see in India, for example, because we are talking about India. In India, we do have two codes, very important codes. One is called the Energy Conservation Building Code, which was first written in the 2010 and then later revised in 2017. It covers all non-residential buildings. But unfortunately, because we are a federal structure, while the code is written for all climates within India and it is very contextual for different states, the states have not really adapted this and ensured their implementation. A few states have done it, but most of them have not done it. So it's still in a state of partial implementation. For the residential sector, the Bureau of Energy Efficiency has come up with what is called as the Eco-Nivas Samhita. Both of these codes are available free of charge on internet, and you can actually download them and read them for those who are interested. So the current status of it is that it is only partially implemented. Just to sort of give you a sense of how we went about creating this green building code, I'm just taking an example of Colombia in this case. It is very important for us to understand the climate of the place, you know. So Colombia really had four broad climates, and so we kind of divided that into four different types. And then we looked at what works in what climate, you know, and so we had a fairly sort of detailed flow chart in terms of we undertook a study of what kind of building stock existed there. So there were local consultants who helped us with this study. We also looked at what kind of building materials and what kind of technologies were available at that time in Colombia. And we also got the idea of the cost. The reason why we were also looking at cost is because these were mandatory codes that were about to be introduced. We had to be very sensitive to the fact that the adoption of the codes did not result in a huge increase in terms of the amount of cost of the building, you know, because when they're mandatory codes, you cannot impose a cost on the market like that. We created an energy and water use model. We put it through what is called as a sensitivity analysis, and eventually came up with an implementation matrix. And then from there, in a very scientific way, we created these technical recommendations that was then publicized across the country, across all professional the subgroups within the construction industry. So we took them to developers, we took them to contractors, to consulting engineers, to architects, to banks, to insurance companies. Anybody and everybody who had anything to do with the construction industry was, we convinced them that this is a good code and that it will not result in a huge amount of cost increase. So we kept the cost increase within 2% of the total cost. So that was the kind of thing that we did, and it's kind of operationalized now. So we had a very simple sort of a flow chart to inform how we would do this entire decision making in terms of how we looked at the cost aspects, the energy saving aspect or the water saving aspect, and how we sort of created that logic for inclusion. So the moment we made this public and we made this known to others, there was much more acceptance of whatever we were talking about, you know. This the code, of course, was inaugurated formally by the president of Colombia, who's seen on the left-hand side here. And it is now in action in many cities. So we also kind of put forth an idea of how this can be, looked at how it can be deployed. So we looked at sort of having an initial warm-up of approximately 6 to 12 months, to ensure that the capacity building within the government happened, within the market happened, awareness initiatives, and then creating and documenting protocols and training of building inspectors. And then we said that we will pilot it in key cities, and then over time it will then be rolled out across the entire country. So this brings me to the end of the green building aspects. Now we have sort of looked at the theory of it, So a lot of us will have a question, while this is all great, I sort of understand most of it, but how do I really put this into practice? And that is where World Bank really, the International Finance Corporation, which is a part of the World Bank group, came up with this very interesting tool called EDGE, which is Excellence in Design for Greater Efficiencies. I was hoping that I could do a demo of this entire tool, but I think our bandwidth is a little low and I'm not sure if I should do that. But I will explain to you this. I'm sorry?
You can check it up. I think.
Yeah, we can check it up. Yeah, we can see. So I will just take you through the logic of this first. What is EDGE? And so just to give you an understanding of who the World Bank is, World Bank was formed in the 1940s when Europe was quite devastated by the Second World War, and a lot of countries across the world actually were devastated, and they needed economic help to revive each of their economies. And that is how the World Bank was formed. It is a multilateral organization. So a lot of countries, more than 200 countries, are members of this bank. They're actually shareholders. And depending upon which country and how rich they are, they sort of invest into this bank on a regular basis. And that money is then used for various kinds of programs across the world. So one of the things that World Bank holds close to its heart is to ensure that poverty is removed from the world. And there's also sustainable business practices which are encouraged across the world. So these are the kind of broad guidelines on the basis of which World Bank works. And it has 5 different sections. What we hear of as World Bank is typically IBRD, which is the International Bank for Reconstruction and Development, and IDA, which is the International Development Association. Both these put together do a lot of grants and loans they provide to various countries. India is one of the benefactors of that, beneficiaries of that. IFC, the International Finance Corporation, which is the one that has started EDGE, is a organization under the World Bank, but specifically to give solutions in the private sector. So it helps invest into companies that fulfill the objectives of poverty alleviation and bringing up economy if it helps the local people there. IFC really helps in investing money or giving loans to private entities. Then there are other 2 organizations which are MEGA and ICSID. I will not go much into that. So IFC, now I'm focusing on IFC. It has what is called as a Green Building Market Transformation Program. So as a part of that, it does 4 broad things. On the left and top side, you can see it provides investment and advisory for banks. So they will talk to a bank like probably State Bank of India or with HDFC or banks like this, and they will have a certain amount. They will help those banks create products which can then support developments like green mortgages or green bonds that can happen there. On the other side, it also provides investment and advisory for building sector. So it invests into property sector. It helps a lot of developers kind of gain expertise and gain strength in areas where green development can happen. Then green building codes and incentives. This was the part of the program that I was where we went to Indonesia and Colombia. And then now the 4th arm, that is the EDGE certification itself. So EDGE certification is what we are focusing on. So what is Edge? Edge is really a software, and most importantly, it's a free software. So you could input basic details of your building. So basically, typically, if you're looking at as an architect, even before you start the building, you would want to know what are the things that I would like to kind of take care of. What are the specific green strategies that I should adopt that will give me good results or good returns. So that is one thing that Edge software helps you do. The other thing is, it also says that it has to be an achievable standard. So what it does is, the moment let's say you're building a little house, and you want to kind of ensure that it's a green building, you can actually you input your data depending upon which location you are in. It takes the climate files of that particular location, and then it sort of gives you that if you didn't do anything with the building, this is what your baseline is going to be. That is, this is how much you're going to be consuming, how much water or how much energy you're going to be consuming. And then you say that you click on certain technical parameters, and then you see how much energy or water you can actually save. And if you come within 20% of energy, materials, and embodied energy of energy, materials, and water, then you know that you have achieved the EDGE standard. I will explain this further in detail, and then you will have a verified green label at the end of the project. So this free software gives you information on return on investment. So what kind of extra money am I spending, and how much time am I going to get that payback in? So that's also an important aspect. So here you can see that it focuses on 3 categories of resource efficiency. There is 20% energy saving that we are looking at, 20% minimum water savings, and 20% minimum material savings. Material savings means embodied energy of materials. Under Edge, you have 3 different types. You have at the basic minimum, if you reach 20% energy, 20% water, 20% materials, then you get what is called as Edge certified. From there on, you can go into Edge advanced, which means that 40% energy, 20% water, 20% materials. That is something that you can do as Edge advanced. And the third one, which is the most ambitious one, is zero carbon, where 100% of the energy is achieved through either doing putting the entire building on solar or some sort of renewable energy, or you purchase renewable energy from somewhere outside. So you invest into a renewable energy plant somewhere else. So that's how you can become zero carbon. So zero carbon is something that is very exciting now. It's a new program introduced by Edge. A lot of clients have shown interest in sort of taking this forward. At this point in time, I would like to even plug, saying that Ramco and institutions like JSS can be looking at long-term sustainability of their own campuses and their own buildings using this kind of a tool. So Edge is available for all kinds of buildings, right from warehouses to hospitals to educations to hotels, offices, homes, light industry. It covers the entire gamut of the type of buildings. The only thing that it probably does not cover is our heavy industries, something like steel or cement, where the building energy component is very small compared to the process energy that is used. And you could be looking at new buildings, you could be looking at existing buildings and refurbishments, or you could even be looking at entire portfolio. So for example, if you are an institution, you would have a portfolio of buildings across different campuses. So you could look at all of that coming under Edge. And as I mentioned, all the different types of buildings that are here. So Edge is now available in more than 170 countries and growing, So the ones that you see on green are all covered by Edge. The ones that are white are typically the more developed nations. So we haven't really sort of looked at it yet. And there are, of course, some nations like Iran and Sudan and all that, which have not come into edge yet. This is a broad idea of the tool. I will try to log in after this presentation, and then I can probably show you a little further. But here you can see that if you go to edgebuildings.com, I saw somebody's comment saying, where can I find edge buildings? It is available on the website called edgebuildings.com. On that you can click Edge app, and then you will get that. So you have design, and this is where you actually enter all the design aspects. Then you go on to energy, water, and materials. And then you start seeing here base utility cost reduction, the incremental cost, and what payback in years. So how does the certification happen? So at first, the Edge, you basically register your project on the Edge app, and then there is a auditor to whom you can, once you submit it online, then an auditor comes and audits it, and then you construct the building, and then once it is under operation, then you can kind of get the Edge certificate done. So this is for the Edge Zero Carbon. You have to get it Edge certified. For Edge Zero Carbon, there is an additional requirement that you need to have the building operational for 1 year, and about 75% of the building should be occupied. And then you basically provide the documentation on renewable energy or carbon offsets, and then you get the certificate after that. So typically, Edge has, your design and construction team is already in place. You can do a self-assessment in Edge. It's very simple for architects and consulting engineers to do that. An Edge expert you may appoint. If your architect or engineer is not able to advise you, you can appoint an Edge expert who can advise on the various aspects of green design and can help you prepare a self-assessment. Then it goes into an Edge auditor. So you have to appoint an Edge auditor who reviews and approves all the compliance documents, and then it goes to the Edge certifier. In India, the Edge certifier is the GBCI, which is also the agency that is responsible for LEED certification. They are a global organization, so IFC has tied up with them in many countries. So GBCI is basically Green Business Certification Institute, and they have the responsibility to train experts and auditors, and they have a very good quality process. So they ensure that the certificates are issued only after due process has been completed. So it gives a certain amount of credibility to the entire aspect. Edge is very interesting in terms of the fact that it has an inbuilt financial calculator. So for example, when you choose a particular type of, let's say I want to put solar water heaters, what is the kind of extra cost that will do? It gives me very easy impact reporting. So I get to know by putting what particular measure will I get what impact. The compliance is fairly simple because the documentation requirements are simple. It is cost effective because the amount of consulting costs come down here. The processing is a lot more simpler. And then, of course, it is backed by World Bank Group. It is really, really kind of easy in that sense to be able to kind of go through the entire process. Just a few examples of projects that Edge is currently certifying in India. This is different kinds of buildings. This is Value Budget Housing Corporation. They have done this VBHC Vaibhava, which is an affordable housing project in South Bangalore, where their project demonstrated a savings of 33% in energy, 29% in water, and 23% in materials. This is another apartment project that's coming up in Chennai, where they have looked at 27% in energy savings, 41% in water, and 69% in materials. And then there is a hospital in Hyderabad, which demonstrated 24% in energy, 47% in water, and 42% in materials. There is a warehouse that's happened just in Ahmedabad, which again has these a hostel in Tamil Nadu, incidentally done by a very good friend of mine, designed by a very good friend of mine. And this also has extremely good savings. So that brings me to the end of this presentation. And before I let you go, let me try to see if I can take you to the Edge website. And so I'm going to click outside and let me open up my website, and then let me see if I can get this opened up.
Let us stop sharing the screen, then I think.
No, I think it's okay. So what I'm going to be doing here is just.
I'm sorry, it's not visible.
It's not visible yet?
No, not yet, sir. I would recommend you can do it again.
Yes, I will do that.
Thank you. You can unmute your video as well, sir.
Yeah, I will do that. Yeah, I'll just share the screen now.
Please, sir. Okay, it's working.
Okay.
Yes, sir. Please go ahead.
So I've just logged into my dashboard, and you can see here. So let me just go to. So on the left-hand side, you can see there are homes, there are hospitality, retail, offices, healthcare, that is hospitals, and education. So these are the various groups under which it comes. And you can see here data for a particular project. So let me just try to bring up a particular project that I've. Let me just mute my video because I think that I'm having a bandwidth issue.
Sure, sir. I'll be doing it from my end, sir.
Yeah, if you can do it, that'll be great.
Yeah, I'll be doing it. Thank you.
I'm having some trouble with this. Just hang on a minute. Yeah. So here you can see I have already entered certain values. So and done certain things. So this is the villa development that we are doing. Which I showed you, where we had solar panels on every roof. So this is just one of those, and you can see here that you can put your project details, the sub project details, and then you go into location. So you can choose India here. You have many other choices. So depending upon where your building is, and once you choose India, then there are about 60 cities of which the data of the weather has been inputted already. So you can choose say Bangalore, and then it asks you for the income category. So this particular one is for upper middle class, and then you start putting in. So if you're, let's say, early part of the design process, you can just put in a basic area, and it will sort of take a default split of the area. So because each area has a different kind of energy and water consumption. So the bedrooms will have a certain energy consumption, the kitchen will have a different type. So it kind of does that little its own sort of based on its own intelligence. Or as you refine your building, you can actually put your own entry into this. And once you do that, you ask whether there is an air conditioning system going to be involved here, a space heating system. So you kind of put all these things. So this kind of a exercise takes about maybe 10 minutes for you to input all the data if you have everything on your fingertips. And then you go to the interesting part of the tool, which is really the way you would look at all the measures. So on the left hand side, you can see that there are various measures. For example, this one, HMEO1, is reduced window to wall ratio. What do you mean by reduced window to wall ratio? That is, if you can reduce the amount of window that is there on your wall, you're also reducing the amount of heat that is coming into the building. So typically, between a wall and a window lets in double the amount of heat than a wall does. So that's a sort of basic thumb rule. You can decide to put heat reflective paint for your roof, for your walls. You put external shading devices on your walls. You put insulation on your roof if you want to. You put external walls, and as you tick various things. So here I already ticked various aspects. So what then happens is that here on the left hand side, there are two graphs here, two sets of graphs. So you can see 4 bars here, in which the first 2 bars are showing me the building energy consumption if I had not ticked anything on the left hand side. As I tick anything on the right hand side, you can see that for example, the fan energy has gone down from 7 to 4. Let's say home appliances has gone from, that is 3 to 3, a little bit that much. Or let's say lighting, it has gone from 14 to 5, depending upon what I have selected here. So under various colors, so you have, for example, high efficiency boiler for hot water, heat pump for hot water, energy efficient refrigerators and clothes washing machines, energy saving light bulbs, various kinds of measures. Your solar photovoltaics, all kinds of measures on the left. And this essentially gives you a sense of how much you're saving here. And that saving takes you and gives you a sense here on. So this building saves me 54.94% compared to an ordinary building where I wouldn't have taken all these things into consideration. Now here you can see how much is the incremental cost. In my case, the incremental cost is minus because I have put my WWR, which is window to wall ratio, is typically lower. The reason that is lower, why I'm getting minus is because windows typically per square foot is much more expensive compared to the wall. So here I've actually reduced the amount of windows, and hence I'm getting a positive or a negative cost increment. So my payback is not reflecting here because of that. If I had put, let's say, if I removed that, then it will kind of recalculate itself, and it should give me, so my incremental cost is 42,000 rupees, and it will give me a payback in 1.83 years. So that's the kind of thing that we're looking at. Now the same thing I can do for water. So here again, I have pre-selected some conditions here, and you can see that the base case has a certain amount of water consumption, and the improved case has a much better improvement. So if you see here, the showers has reduced from 66 to 46. So there is a savings there. If you look at the kitchen, it reduces from 106 to 80. And if you look at water faucets, 35 to 26. And if you look at water closets, 70 to 33. One thing that I have not taken is washing and cleaning, because I have not selected any particular kind of washing machine. So because of which it doesn't reflect. So, and then you can say that if you want to, let's say, recycle all the black water for flushing, for example, so then it further increases. So you could see that earlier my energy savings was lesser. Now it has become 37%. So that's the way you can kind of, so you get a very immediate feedback into everything that you do. Now I'll go to materials. So in materials, for example, we have in situ reinforced concrete slab. Now, the moment I click on this, I get a lot of choices here. So I can go for composite slim slabs. I can look at concrete filler slab with polystyrene blocks. There are many technologies which are here. So you can look at all the various technologies that are available for floor slabs, for roof construction, for external walls. So for example, here, let's say now our embodied energy material is at 57. So let us say that I go back to burnt brick, which is the default material. Common brick wall. And then you can see that it has come down by 20%. So you can see that how much that wall really matters. So if I go back and select solid dense concrete block, it goes up. So this is the kind of thing, or let's say PVC window frames is what I've selected, but let us say I want to go with aluminum. So let's say I do aluminum, for example. And then it comes down by about 8%. So obviously, this way I can kind of show this to my client and then convince them very easily, saying that, look, it costs almost the same. Let's go for something better, So that's the kind of thing that we're looking at. So this is essentially the tool. And here you can see above what's the kind of utility reduction. That is how much electricity, water, and gas I will be saving. So all that kind of gets reflected out here. And eventually, you will also it will also give you how much carbon emission you have saved. So you're saving about 2.5 tons per year. So that's a good saving that you're doing. So these are various ways of kind of. So you get a very mathematical sort of a view in this particular tool. So, and the best part is it's free. So you simply have to create a login and password, and you can start inputting all your projects into this. And if you require further help, there are people like us who are in the market who can help you sort of go take this further into certification and auditing. So I will just switch on my video back. I've come to the end of my session. and maybe I can stop sharing. I would, if there is time, I know I have overshot all time. So if there are questions, I'll be happy to answer them if the organizers want to do that, or we can take it offline and do that.
Okay. Thank you so much for the presentation. In fact, you have touched upon two important aspects. One is, you have touched upon the economical aspect of being green. That is very important, because saving money when you are turning green over the long term is what is, that is a very important message. And another important thing which came to my mind was that you have constructed a green building, but how do we reach there? So in that aspect, you have covered that aspect on roads, which is very important. How to approach the green building. We have created a green building, but if you are going to consume more energy in reaching the green building, then what is the use? So
Exactly.
very, very interesting presentation. There's a question by Dr. S.P. Anchuri. Can we take it?
Yes, of course.
Yeah, what he was saying is that nice talk. Need of the time is CCC, collaboration, coordination, cooperation, which is neglected by students and literally lack in college as well as in all engineering departments, work in isolation. How can we bring integration to achieve green built environment?
I think it definitely starts. I think there has to be a greater industry academia connect on this particular aspect. In fact, the World Bank has started a program, IFC has started a program where we are reaching out to universities across the world, where we can look at actively engaging with the faculty on a training of trainers program, a TOT program. In fact, I was a part of that TOT program. We did this program in Vietnam, and before that it was done in Indonesia. And I think they are planning on a program even in India, which is going to get rolled out soon. But so one aspect is that of the industry academia connect. The second thing is to also look at uh, creating a market demand, really, and one of my efforts has been to popularize green buildings as much as possible, almost in an evangelical way, with my clients, with other developers, and with the intention that you create a market demand. The moment there is a market demand, then everything else sort of falls into place, because market is the best way that you can push any aspect. When there is a market, then the services for that comes through. So there are a lot of consultants already in this field, and there are organizations like CREDAI and like IIA and IIID who are trying to bring all these people together, even ASHRAE and ISHRAE, for example. So I think it is a multi-sectoral, multi-organizational kind of effort that we need to kind of look at this. So broadly, industry associations, and academia. If these three components can come together, then we can really kind of take this forward. In fact, what we are doing today is an excellent example of that. So you have Ramco as an industry, you have JSS as an academy, and ACCE as the industry association. It kind of increases the reach of these kind of messages, and more and more of such interactions.
Another question is by Mr. Manjunath. He was saying, what is the percentage of cement usage and concrete contribution in sustainable environment? I think it all to my mind, it depends that, it all depends on the usage, whether we are going in for optimum mixed design or usage of blending material. Anything which you would like to add on this, like, he wanted to have a percentage. I think it's very difficult to put a percentage, I believe.
Very difficult to put a percentage on this. But like you very rightly suggested, I think our job as either educationists or as specifiers should be to try to look at blended cements more and more as we go ahead. So look at PPC, look at PPC with either slag or with fly ash. I think all these kind of really help. And today, these are proven technologies, and I think we as consultants can play a huge role in terms of trying to bring in blended cements more and more, especially into our concrete and various other products.
And of course, economical mix designs also will play a very vital role.
Totally.
Another question from Mr. Prasad is saucer drain has been explained very clearly, but why
Yes.
they have been becoming very popular easily? Any drawbacks in that?
If you look at, I think the issue remains, saucer drains are becoming very common, especially if you look at any gated community. So any private developer who's doing layouts, you will start seeing more and more saucer drains. I think it is a matter for the government agencies like BDA and other urban development authorities who are involved in large scale road planning, who need to adopt this. Technical material out there. There are enough technical people out there who can help with very scientific road designs. I think it's just a matter of the government actually accepting it and trying to make it as a part of their specifications.
So under Dr. Ajit Sabnis complimented, he said, excellent information. Thank you, Architect Vasudevan. And he also wanted to make a point. NBC 2016 has included excellent information in its volume 2. In fact, I have got that code with me. I think
Yes.
in part 11, yeah, we have got that. So he wanted to make that, yeah. You want to add something on that?
Absolutely. I think, yeah. So, sustainability is now a new chapter in NBC 2016, and it's great to have that. Just by simply following that itself, you will get a lot of tips as to how to bring in sustainability.
Another question by Dr. Ajit Sabnis himself. Do you have database of energy consumption for different building typologies per square meter?
I don't have it offhand, but it's a very good question. And what I can point you towards is a particular factor called EPI, Energy Performance Index. So Energy Performance Index is typically measured as the number of kilowatt hours per square meter per year that a building consumes. So if you go to ECBC, Energy Conservation Building Code 2017, it will have a set of ideal EPI that you need to conform to. So that is something that you can do. Also, Edge tool provides EPI. So if you look it in the right corner, you will get the EPI there. So that is one aspect. Now, I know that this is not an asked question, but I want to have one more related question. Is the aspect of how do you know which building is more eco-friendly and which is less? So this is also a part that plays an important role, especially as a specifier. And we can look at databases. Edge itself can give you. And if you go deeper into the Edge website, there is an entire report, a free to download report, which talks about the embodied energy of various materials. So you can look at that. So both these aspects give you, both these are ways of looking at it.
Another question by Dr. Ajit again. What is your view on sustainability assessment at the conceptual stage itself?
I think absolutely it is totally important. We need to start the idea of sustainability right from even before we develop the concept. That is where actually a tool like Edge helps. Simply have simple figures. For example, how big is your site? How large is your building? How many floors are you going to build? You will have these basic back of the envelope calculations even before you actually put your pencil to paper the first time. So you can use Edge as a very good tool in direction. You can keep refining, and hence you will get a refined output. So
I think there is some problem in the bandwidth also. Thank you, Dr. Ajit and Dr. S.P. Anchuri for the questions. And there is another question. Is embodied energy accounted in Indian context? It is by Mr. Mohammed Sharjeel. I think we have some problem in the bandwidth. Yeah. So I think some of the questions we will take it through email. So meanwhile, let me go over to Dr. Santosh for the vote of thanks. A fabulous presentation. Over to you, Dr. Santosh. You can just, yeah.
Yeah, thank you very much, sir. I request Apurva to present the vote of thanks.
Sorry, could you just repeat that question?
Is embodied energy accounted in the Indian context?
Yes. So if you go to the EDGE website, there is a special report on the embodied energy. The World Bank actually, the IFC actually did a initiation of the study. So it is available, and it is a developing science, and I'm sure you can look up.
All right. Yeah, we can go on with the vote of thanks. Yeah, thank you so much for the presentation and clarifying the questions. So let me request Dr. Santosh to go on for the further proceedings. Vote of thanks.
Yes, sir. I request Ms. Apurva to present the vote of.
Yeah, I think she's.
Sir, seeking the blessings of His Holiness Jagadguru Shivratri Rajendra Mahaswamiji and Jagadguru Shivratri Deshikendra Mahaswamiji, it's my honor and privilege to deliver vote of thanks on behalf of Department of Civil Engineering and Center for Interdisciplinary Research, JSS Academy of Technical Education, Bangalore, Association of Consulting Civil Engineers, Bangalore Center, and Ramco Cements Limited. I would like to thank our speaker, Ar.Vasudevan R, for accepting our invitation and for taking his precious time in delivering the topic Demystifying Green Buildings and EDGE Discovery Workshop, which enlightened us with the information on global warming, embodied energy, urban sustainability, green building codes, and also about the tool EDGE. More than 1,000 participants from all over the globe has participated in this event. On behalf of organizing committee, I express my heartfelt thanks to all the participants. I express my thanks to Association of Consulting Civil Engineers, Bangalore Center, Mr. Rajesh Kannan, Chairman, Mr. Shrikant, Secretary, and Mr. Savina, Treasurer, for their association to make this event successful. I extend my gratitude to Ramco Cements Limited, Mr. Anil Kumar Pillai, General Manager, Technical Services, Mr. Shashank and Mr. Suraj, and the whole team of Ramco Cements for their association in conducting this event. I also express my thanks to our beloved principal, Dr. Mrutyunjaya V. Latte, JSS ATEB, Dr. D.R. Swami, Chief Coordinator, Center for Interdisciplinary Research, and Dr. Santosh B.S., HOD, Civil Engineering Department, for their support in making this event successful. Last but not least, I would like to thank all the organizing committee members. Once again, I thank you all for your active participation. Thank you.
In fact, this was the 90th webinar. And let's meet on Monday at 11 a.m. Again, there would be an interesting presentation by Mr. Sanjeev Parekh, who is the Managing Director and Chairman of SPA Consultants based at Calcutta. So we would be again meeting on 11. Anything that you would like to add, Dr. Santosh?
No, sir. Really, it was a very fruitful.
So we sign off. Yeah. Yes, please.
It was really enlightenment regarding the presentation. We got a lot of information from morning session and this session. We got a lot of information regarding the green building and also how this global warming is causing and how it is an alarming situation in the future and how we need to overcome or how we can reduce that global warming by adopting some of the innovative methods which was put forward by Vasudevan sir and Rohan Parekh. So I take this opportunity to thank both the speakers and personally Anil Kumar sir also for moderating this event, sir.
Thank you so much. So we sign off from the event. Take care. Wishing you all the best. Thank you so much.
Thank you.
Thank you very much.